next presentation, which will be given by myself. So I kind of introduce myself. I'm Jacques Haesler from CSEM, project manager, and I will mostly show you what is CSEM, present you what is CSEM. On the technology part, you already heard what Sylvain was presenting on the development in Maximal, on the atomic vapors, cells, on the atomic clocks, and all other applications. I'm going to focus on CSEM itself. So, but still mentioning the atomic clock, the gyro, and non-classical light sources. CSEM is an RTO, so a research and technology organization. We are 500 people working in Switzerland. So we have our headquarters in Neuchâtel, but we have other subsidies you will see afterwards. And we cover different applications. So most of our application is in space and scientific instrumentation. It's 1/4 of our industrial sector where we are working for. But also for sure, we are working for the watchmakers. So this is the history of CSEM, which was the R&D facility for watchmakers in the 60s and 70s and so on. But we cover different applications that you see here. And this is also a good point from CSEM, that we cover as much as possible what the Swiss industry wants to have. As said, we are located in Neuchâtel, near to the Watch Valley, a very nice city. Always you're welcome to visit us. And especially we are working on the old observatory site, which is a very nice place to work with a lake view. So again, you are welcome to visit us. In order to be as close as possible to the industry, we have different subsidies. The headquarters, as I said, is in Neuchâtel, but we are facilities in Muttenz, Basel, in Zurich, in Alpnach, so central Switzerland, and also in Graubünden, Landquart. And we have also a sister company in Brazil working in different fields like LTCC or photovoltaics. We have different technology that are in focus at CSEM, and they are grouped in 5 different focus areas. So there is a precision manufacturing, there is digitalization, and sustainable energy. And the quantum technology is in the digitalization focus. On our own, we could not live. We have to ask for competences in other focus areas like MEMS and packaging, like photonics. We heard about PICs before. We also are active in PICs, and we work with Ligentech also for such kind of things. And for sure, we build systems. So we need to have the knowledge of scientific instrumentation people that have either mechanical design, electrical design, microfabrication design, and so on, that helps us to make systems at the end. The 3 groups that are involved in quantum technology at CSEM is the quantum tech and laser group, and also the LIDARs. In the quantum tech, as explained also before, the history comes from the atomic clock. There is a whole history in Neuchâtel on the atomic clock world. And thanks to the developments, to the investments also made by CSEM, by the government, we could get to the point where we are now. So helping the industry to put new product on the market. And also thanks to these advancements and to these results, we were able to target new applications like we'll show afterwards, gyroscopes, magnetometers, or other kind of sensors. We also work on the building blocks, so the lasers, not only for atomic clocks, for quantum devices, but all kind of lasers for very stable laser, for the space application, for the LISA mission, for example, for the gravitational wave detections, and also miniaturization of components that allow to build comms. These are fields we are active on. On the LiDAR point of view, we also already demonstrated flight models that were showing that we could remove debris in space thanks to vision and 3D capture of a LiDAR. Now we are also working on ground application for LiDARs like bathymetry. So going to put our LiDARs under the lake, under the sea, underwater, and see what happens there, to see some pipelines, some archaeological pieces under the lake, things like that. Regarding atomic clock, as said, you already heard what Sylvain was saying before, but just to make a picture where we are. So there is currently a push in the market to have miniature atomic clocks. There are two in the market for the time being, one from Microsemi and the other one from Orolia now in Switzerland. It's not perhaps a cheapskate, it's a miniature atomic clock. And the goal is to help now the Swiss industry, and why not the European industry, to have a product that is competing with the one from Microsemi in the States. So we're working on miniaturization of our atomic clock, making it smaller, less power consumption, and also bringing the costs down. And we are working at the system level, as I said before, from the vapor cell to the laser, to the optics, the packaging with VTT, the electronics, trying to reduce further the power consumption by using integrated electronics, and the full packaging. But most of the work has been dedicated to the development of atomic vapor cell. And you can ask perhaps why we are patenting such things. And the goal is always to help the industry so that they can also use these patents and to protect themselves when they want to put a product on the market. That's why also we are working on patenting things. Maximal is the output of all this research, and Sylvain showed you the different examples and the objectives that we are planning to reach within this project. Coming back to the gyroscope, so Sylvain was showing you the application of autonomous vehicle with our partner Bosch. I would just like to show you another example. So using our atomic vapor cell, we can also target an application for small aircrafts. So you can imagine that in big aircraft, they have sufficient place, power availability, and also the cost is perhaps less important. But if you want to make an alternative positioning, navigation, and timing system at lower cost that you can afford for a small aircraft, you have somehow to reduce the cost of the system. And using atomic gyroscopes, thanks to the MEMS facility, is the goal to reduce the costs. And we hope that once we will be able to offer to small aircrafts new APNT systems. One of the key advantages that we have also at CSEM is we master the measurement of non-classical light sources. And thanks to two projects, one is called FOG, also in the Quantum Flagship, where they develop a photon gun. And the goal is to test this photon gun, so non-classical light sources that can help having better performance for atomic clocks. And one of the showcase would be the cesium beam clock, in which we will replace standard light source by non-classical light sources. And finally, the Super Twin project, by using entangled photon sources and using also single photon detectors, we could show that we can improve the resolution of microscopy going below the Rayleigh limits and having high resolution microscopes available for the everyday life, let's say. With that, I'm finished. Again, please visit our website, csem.ch or maximal.eu, and contact me if you have any further questions. Thank you very much for your attention. George, do you have some question?
There is no direct question. I raised a little bit the question why I should not choose CSEM if I'm a quantum engineer. I mean, this looks as a great step into a career to be done by a student which just finished.
So there is no reason not to choose CSEM. That's an easy answer. Now we offer really either PhD positions, so making a PhD in industrial environment or pre-industrial environment. We offer for sure a fixed position as physicist, as electronician. So visit our website, there are open positions and we are looking for talented people. And also thanks to you, George, for the master student in quantum technology. Thanks to that, we'll have the next students, the next employee with the capacity to work in this field. Thank you, George.